Hey there. In this module, we're going to discuss mixed analysis of variance or mixed ANOVA designs. Mixed designs basically combine the previous two designs that we talked about. Basically combines the repeated measures ANOVA and the factorial ANOVA that we've discussed in the last two modules. In this module, we're going to have one within subjects, a repeated measures variable, and then one between subjects variable in the ANOVA model. We're going to stick with examples of the one between, one within mixed design, but they can get a lot more complicated really fast by adding in more repeated measure variables or more between subject variables as well too. So in this video, I'm just going to kind of walk you through all the materials and resources that are available on Canvas, and then give a little brief lecture on mixed analysis of variance. With all the modules, make sure you start out with the README file. It contains in here our assigned readings for the topic. I've copied this chapter out of the Stevens multivariate textbook on repeated measures analysis. I'd specifically check out these pages where they go over a one between and one within mixed design, and then you can check out the following 7 pages from some additional mixed designs. The beginning of the chapter really focuses on the repeated measure designs that we've already covered. This field reading here has a good walkthrough of an example and walkthrough interpreting it in SPSS. And then also there's a zip file you can find here with some additional readings too for mixed designs, as long as these two are required readings. Here's also links to the assignment and quiz for this week. You can also download the readings for this week here in this zip file. Here's some brief notes that I've made, kind of hitting the high points of mixed ANOVAs. We'll walk through this in a minute. There's also some resources for running a mixed ANOVA in SPSS. Here's a video where I walk through the example that I talked about in the notes, and then I give you in this demonstration here. So this should take you to a YouTube link that walks through the video. The videos don't open here because YouTube refused to connect. Just click the link at the top and it should take you to the YouTube site, and you can see my walkthrough. I also have some annotated output here with here are the steps to run a mixed ANOVA in SPSS. Here's an example research scenario. Here's some example data. Here's what the data look like when they're entered into SPSS. And here would be your SPSS output, and I've tried to annotate what all you would do. Here's boxes tested the quality of covariance matrices, how you interpret it. There's our test of spherosity again. We'll talk same thing with repeated measures ANOVA. So I kind of walk you through again the output, trying to help you interpret each one of the tables that are on here. And there's more detail. I kind of go through that in the walkthrough video here. There's the data set for this example, the SPSS data set. You can download it here. Here's the SPSS syntax file, because we'll be doing a simple effects analysis like we did in the factorial ANOVA. So there's a syntax file for it. Here's an example write-up of this example that we go through in the video. This is how I would write up the results from that analysis, so you can see that right there. And then I've also provided. Here are just some additional mixed ANOVA printouts. This was a resource Dr. Marr had provided to some of her students. I don't have the data that she used in here, so I kind of just annotated some of the output, some additionally for you in here too, so you can kind of hear some additional outputs and how you might interpret them as well, to kind of familiarize yourself with the mixed analysis of variance. There's not too much that's new in this module, because like I said, mixed ANOVA is really kind of a combination of the repeated measures ANOVA and the factorial ANOVA that we covered in the last two modules. But I have made some notes here that kind of hit the high points for some of the readings to kind of give you an overview of what we're talking about. So, in a mixed analysis of variance, is where we have one or more between subject factors and one or more within subject factors in the design. And here we can also look at an interaction effect between the between subjects variable and the within subjects variable as well too. Some of these assumptions should seem very familiar to you, because we're basically kind of combining the assumptions from repeated measures ANOVA and factorial ANOVA too. So we have our normality assumption that the population distributions are normally distributed. We have our a new one actually for this time is this homogeneity of covariance matrices, which is basically saying that the variance and covariance for each one of the repeated measures are the same within each of our between subjects variables. So does that make sense? Like the repeated measure, the level of the repeated measures variables should be the same for all of the between subjects groups. So if we're looking at, say, the impact of math achievement over a 3-month period for both males and females, then the variances and covariances between those 3 time points that we measured math achievement should be the same for both males and females. When group sizes are equal, violations of the assumption aren't too severe, and we'll get a little test in SPSS boxes test. I think it's boxes M test that will kind of assess this assumption for us. If we violate this assumption, we might try using a more stringent alpha level, or even going to a maybe like an alternative test as well. We have our friend, the homogeneity of variance assumption from factorial ANOVA. So it's basically, the population variances of a between groups variables should have equal variances. And then, the consequences of violating this assumption are the same as they were in factorial ANOVA. Same thing with the sphericity assumption from repeated measures ANOVA. This is the same assumption, basically that the variances of the differences in the pairs of all of our repeated measures are the same. If your within subjects variable only has 2 levels, like a pre-test, post-test situation, you don't have to worry about sphericity. But this is the same idea as it was in the repeated measures case, and the same consequences for sort of violating the assumptions as well. Some other important data considerations to kind of keep in mind. You could always check your data for outliers or extreme cases that might influence the results. And missing data and unequal sample sizes could have an impact on the power of your study. For this lesson, we'll kind of ignore these different data consideration issues, and we will talk about those in more detail if you take Stat 3 next spring. Here I've just listed some advantages and disadvantages of mixed designs. I won't read through it all for you, but one advantage is mixed designs are generally are usually more generalizable than just regular repeated measures designs because we're controlling for another independent variable, and we're looking at the interaction between subjects factor and our repeated measures factor. Remember, that was one of the disadvantages of repeated measures design was generalizability, and a mixed design then can become an advantage. Power also increases here because we're having a smaller sampling error, smaller error term than with the repeated measures, just a single repeated measures ANOVA, because we again are adding another factor in the design. Some disadvantages. These models can get very complex very quickly. Like I said, in this lesson, we're going to talk about the one between, one within design. You can see at the bottom of these notes, there's an example of what's it called? It's a 2 by 2 by 2 by 2 by 9 design. So you can see they can get pretty complicated pretty quickly. There's also no non-parametric equivalent to the mixed ANOVA. It's not saying that there's nothing else you could use, but a lot of times people will violate some of these assumptions. I need to switch to a non-parametric design. It's not really an option here. However, you could use a multi-level model or a linear mix model is another excellent alternative that you could also consider using. Here I give you a quick little refresher on interaction effects. This should be familiar from what we talked about last module for the factorial ANOVA. Just like in factorial ANOVA, we have 3 F-tests. We'll have an F-test for the between effects, an F-test for the within effects, and an F-test for the interaction. Move my head out of the way there, you can actually see the term. And we'll kind of follow the same rules that we did in factorial ANOVA. One of the first things we're going to look at is the effect of the interaction term. And if the column follows the same rules, if the interaction term is statistically significant, we are going to ignore the main effects and run a simple effects analysis. We'll also plot our data to help interpret the interaction. So it's going to be the exact same rules this time, though. Instead of the interaction being between two between subject variables, it's the interaction term is between a within and a between subject variable. So it would be an interaction between our grouping variable and our repeated measures variable. And the interaction is still saying the same thing. Does the influence of this independent variable change or depend, the influence of this independent variable on the outcome depend or change depending on the levels of your other independent variable. Here we really have 2 different simple effects analysis we can do. We can have a simple effects analysis for the within subject factor and a simple effects analysis for the between subjects factor. So, the simple effects analysis for the within subject factor, basically what we're doing in the analysis is we're selecting on each level of our between subject factor. So if we take that example I was mentioned earlier about the influence of let's say mathematics achievement over time and gender. If there's an interaction effect, it would say that, you know, the influence of mathematics achievement over time depends on the gender of the student. So we could look at, for the simple main effects analysis for the within subjects factor, we would select on males and run a one-way repeated measures ANOVA on our time variable for our different repeated measures. And then we would select on females and run a one-way repeated measures ANOVA for males. A simple effects analysis for the between subjects factor, you would select on each time frame. So at time 1, is there a difference between males and females in their math achievement? We select on time 2, is there a difference between males and females in their math achievement? You select on time 3, is there a difference between males and females in their math achievement? So you could run and actually interpret both of those simple effects analyses. And I think that'll make the simple effects analysis, those two will make a lot more sense when you go through the SPSS, the demonstration video. We'll actually run through it and interpret them. So here's like an example research scenario. So say a researcher is interested in comparing the relative efficacy of a behavior modification approach to dieting versus a behavior modification plus exercise approach on the weight loss for a group of overweight men. There's also a control group in the study. So in this design, 12 men are randomly assigned to one of the 3 treatment conditions. And then weight loss is measured at 2 months, 4 months, and 6 months after the program begins. So in this case, our dependent variable would be weight loss. Our within subjects factor would be time, right? So it'd be weight loss at 2 months, 4 months, and 6 months. And our between subjects factor, independent variable, would be the diet program that the participants are in, whether it's a behavior modification approach to dieting, a behavior modification plus exercise approach, or if they were in the control group. So you can see there, so you can see how this is then a 3x3 mixed ANOVA design. So we'll have then a main effect for the diet program, a main effect for time, and an interaction effect for the type of diet program times time, or diet program by time. So if there's a significant interaction effect, it would say that the amount of weight loss over time then depends on which diet program you were in. And you could do the simple main effects analysis to determine how that effect is manifested. If there's not a significant interaction effect, then it's saying that the impact of diet program on weight loss is the same at each one of the 3 time periods. And we could then interpret the main effect for diet program and then the main effect for time to see, is weight loss greater at one of these time periods than another, and then is weight loss greater for one of these diet programs, averaging over the different time periods. You can see, so I've made the SPSS demonstration. So I'll go through this example we just talked about here, this diet weight loss example in the mixed ANOVA video, and also in the demonstration document. There's also some additional interpretation documents I pointed out on Canvas. Here's some other helpful YouTube resources. Here's another general overview kind of lecture on mixed ANOVA and some other example research scenarios. Here's a couple videos on assumptions for mixed ANOVA and kind of testing for those assumptions. Here's another walkthrough of conducting a mixed ANOVA and interpreting the output. And here's another example of a little more complex mixed ANOVA design. In this example, there are 2 repeated measure variables and 1 between subject variable. So kind of check out those videos too, kind of help you orient yourself to the mixed ANOVA design. You really just need to keep in mind that we're really combining the concepts that we talked about, the 2 previous modules together. Down here is an example. Remember I talked about how these mixed designs get complicated really quickly. Here's an example of a 2 by 2 by 2 by 2 by 9 mixed design. I think this 1, 2, 3, I think there was 4 between subject variables and then 9 repeated measures on here. So you can read about how these people wrote up the results of this study, and so you can see kind of how you present the results of a mixed ANOVA and kind of how they can get complicated pretty quickly there. You know, if you don't, you're not meeting some of the assumptions of the mixed ANOVA, or you need a more flexible model, you get people who drop off. They were there for, my first measurement occasion. They missed the second, came back at the third and fourth, or they were there at the first and second, dropped off at the third measurement occasion. In the mixed ANOVA design, if you do not have a measure for a participant at every single one of your repeated measures, then it drops that person completely out of the analysis. So say you were, have any kind of drop off, someone doesn't show up at time 2 but comes back for time 1, time 3, times 4, times 5, we'd have to exclude all of their data from the mixed ANOVA is going to drop them out of the analysis. You might want to check out what are known as multi-level models or linear mixed models. They might be called hierarchical linear models. Discussion of this is really beyond the scope of this class. But if you're interested, our department usually offers a multi-level modeling course every couple of years. And there's also some additional information in the, with some additional resources and the alternatives to repeated measures ANOVA. A document that was one of the readings for repeated measures ANOVA that they extend easily to a mixed case as well. So if you're interested in that, check that out or talk to me, and we can talk about it some more as well. Like I said, there's not that much new to talk about this week, especially since it's really a combination of what we've been, mixed ANOVA is a combination of really factorial ANOVA and repeated measures ANOVA. I would definitely spend some time looking through the interpretation document so you can kind of get a sense, especially to wrap your head maybe around the simple effects analysis. And you can see in here, I do the simple effects analysis both ways. For the within subject factor, where we're selecting on each one of our betweens, so we're selecting on each diet program in this case, and running a one-way repeated measures ANOVA for each diet program. And then we can also run the analysis here for the between subjects factor, where we'll select at each time period and see, is there a difference between the diet programs at each one of the time periods. And if you look at the profile plot, in this, the simple main effects analysis for the between subject factors, we're like comparing these times over here and diet programs on our separate lines. You know, this is weight loss or outcomes on the y-axis. So the between subjects, as we're selecting for the between subjects simple effects analysis, we're selecting in each time frame, selecting at time 1, and comparing the 3 different programs. Selecting at time 2, comparing the 3 programs. Selecting at time 3, comparing the 3 programs. For the within subjects simple effects analysis, we're selecting each DAT program, and we're comparing, say, you know, DAT 1 at time 1 and 2, DAT 1 at time 1 and 3, and DAT 1 at time 2 and 3. Same thing, comparing DAT 3 at time 1 and 2, DAT 3, compare time 1 and 3, and then compare time 2 and 3. So that's kind of just an overview of how the simple main effects analyses work. You know, as always, if you have any questions, concerns, you know, shoot me an email, post to the message board. I am here to help. Thanks. See you next module.